Hello students, welcome back to today's class on playing with numbers. Playing with numbers, the name itself says that we are going to play with numbers and it's a very interesting topic. Let's start today's session. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start the class. So what are we going to discuss in this chapter? It's all about numbers. And what I mean by playing, okay, let us try to say that a number is given, for example 556, but I don't know whether that number is divisible by 4 or not, divisible by 3 or not, divisible by 5 or not, right? So how to see when the number is given, how to find whether it is divisible by some number or not. So without the actual divisions, that we are going to discuss in today's class. Okay, so let us try to take one small situation. Ravi and Raj, there are two friends, Ravi and Raj. Okay, so Ravi said to Raj, think of a number. Okay, let me think of a number. Okay, so let us say a number 57 or 52. Let me say the number is 52. Think of a number, reverse the number. Reverse means just till these numbers. Okay, it can be any digit number, don't worry. Okay, here I'm taking a 2-digit number. Add both of them. Okay, 5 plus 2 7 and 5 plus 2 7. Good. Okay, let's see what result can we get. And Ravi is saying, I'm sure there is no remainder when the sum is divided with 11. There is no remainder. What do you mean by no remainder? That means the remainder should be 0. Remainder should be 0. 11 and 77. If you divide with 11, 11 sevens are 77. And yes, the remainder is 0. Right? When the sum is divided with 11. But the thing is, how come he know my number is 77? Okay, let me try with another number. Okay, let me take 34. Okay, or 32. And another number 23. So 3, 4, 5, 3 plus 4, 2, 5. 55, yes, it is also divisible by 55 is also divisible by 11. Okay, so how could he say without knowing this number that this number is divisible by 11? That means there is some logic behind this one. There is some rule behind this one, right? So such type of rules exist for many other numbers. So all those we're going to learn today. Okay, so the first one, we're going to learn about expanded form of a number, okay, which you already know, which you have already discussed earlier, okay, in the lower classes. But once again, let us try to discuss about expanded form just in 1 or 2 minutes. And then we're going to discuss about divisibility rules in this class. And after that, we're going to discuss about factors and multiples. Even factors and multiples, you are aware of that, but let us try to have a small recap of all those, right? The first one we're going to see, let us try to see what is a place value. Okay, when we are discussing about expanded form, what do you mean by expanded form? Let me tell you that. Okay, for example, you want to expand the number 7369. What are place values? Do you remember? Place value is a units place. That means a 1. Tens place, hundreds place, thousands. If more numbers are there, 10,000s place, 1 lakhs, 10 lakhs, 10 crores. Okay, so all these are the place values. Now, what is expanded form of this number 7369? 7369, see, this units place, okay, ones place, units or ones place, 7369, okay. The number after that will go for tens place, the number after that will go for hundreds, and the number before that will go for thousands. Always you should come from the right to the left. Don't go from this number, ones, tens, hundreds, no, that should come from the other side. Okay, so once 9 into 1 will give you 9. That means the value of 9 is 9. But for 6 into 10 will give you 60. The place value of 6 is 60. In the same way, hundreds, 3 into 100 is 300. Right? And 7 into 1000. 7 into 1000 is 7000. 7369. Those are the place values, and that is how we write expanded form. Okay. Let's move ahead. Write the following numbers in expanded form. Very easy. Okay, you already know that. One example is also given. 25,984. 25,984, and we also know how to use commas, correct? 25,984. So 4 is in ones place, okay. The next 8 is in tens place, 80. 9 in hundreds, 900. 5 in thousands, 5,000s, and 20 in 10,000s. I mean 2 in 10,000s, that becomes a 20,000s. 20,000. 20,000 plus 5,000 plus 900 plus 80 plus 4 will give you 25,984. 25,984. In the same way, the next one, 95,843. 95,000. So come from last. 3 into 1 is 3. Okay, that is the same 3. Next, for 4 it is 40. Okay, 40. Next, 8 is in hundreds place, 800. Plus the next number is a 5, which is again in thousands place, 5,000, and 9 is 90,000. It is in tens place and it is in 90,000. Okay, 90,000, 5,843. Correct? In the same way, you can write these two. Okay, you already know how to write this one. We have already discussed that in the previous classes. Okay, so let's move forward. Let's try to take the first divisibility rule. Okay, divisibility rule. What do you mean by divisibility rule? I told you, if you take a number 56, how can you check whether that number is divisible by 4 or not, 3 or not? So there should be some logic behind that without the actual division. So that is called divisibility rule. The process of checking or verifying whether the number is divisible by a given number or not without the actual division is called divisibility rule for that number. It's called the divisibility rule. Okay, let's try to have a small discussion. For example, 10 is there. Do you know whether 10 is divisible by 10 or not? Yes. 20? Yes. This is 10 into 2. 500, 10 into 50. Yes, it is divisible. 80, 8 into 10 or 10 into 8. 8690. 10 into 869. So all these numbers are divisible by 10. How can I say that? What logic is there? What logic is there hidden inside that as soon as I see the number, I can say that it is divisible by 10 or not? Okay, you can see here every number ending with 0. This is very important. All these numbers are ending with 0. Careful observe. All these numbers are ending with 0. Every number ending with 0 is divisible by 10. Every number ending with 0 is divisible by 10. 234, is it divisible by 10? No. Why? It is not divisible because there is no 0 at the end. But what about this number 23402? Although we have a 0, but we don't have at the end, at the units digit. We need to have 10 at the units. The number should be ended. The number should end with 0 at the units place. Okay. So now what about this one? Yes, this complete number is divisible by 10. Okay. For 10 it's very simple. But let us also try to see the other divisibility rules. The next one we are going to discuss, the very first one in this sequence, that is divisibility by 2. Divisibility by 2, you know that 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, so on. So many numbers are there, so many numbers, right? So I'll take some arbitrary number 1,01,453 and I ask you, is it divisible by 2? And you should not sit and divide everything. We need to have a small logic behind that. So what is that? You can see a number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. What do you mean by ones place? Units place. In that ones place, if you have any of these numbers 0, 2, 4, 6, 8, we can say the number is directly divisible by 2 without any other thought. Okay, you can see here 126 is there and the number in ones place is 6. So now tell me, is 6 divisible by 2? Yes, because 0, 2, 4, 6, 8. The ending digit is 6. Yes, it is divisible. That's it. For the number 2, I can even I can say that more easily, all these are even numbers. All these are even numbers, correct? A number is divisible by 2 if and only if it is an even number. So just by seeing the number, even or odd, even means it is divisible, odd means no. Even 100%, odd 0%, true or false, even is true all the ways. Okay, 332, 2 is there, even number in one's place, it's 2. Also you can say that it is an even number, and if it is even number, it is divisible by 2. 487, 7 is not an even number, and so it is not divisible by 2. 128, yes, 8 is an even number, 8 is in one's place, right? 569, no, it is an odd number, it is not divisible by 2. If you want to verify, you can take any number. Okay, don't have to take big numbers, you can also start with small numbers. You can see 12, 14, 16, 18, 20, all these numbers are divisible by 2. But all the odd numbers, 11, 13, 15, 17, 19, so all these numbers are not divisible. All these numbers are not divisible. Understand? Let's move ahead. Let's go for the next one. Divisibility by 3. Just now we discussed about divisible by 2. And what is the logic behind that? Divisibility by 2 means every even number is divisible by 2. Or the ending digits should be 0, 2, 4, 6, 8. The same way, there is some logic for 3. What is that? Let's try to see here. A number is divisible by 3. We are discussing about 3. If sum of the digits, what do you mean by sum? For example, I'll give you 123. Sum of the digits means add all the digits. 1 plus 2 plus 3, 3, 4, 5, 6. 6. 1 plus 2 plus 3. Is it divisible by 3? Yes. If sum of the digits is divisible by 3. Is divisible by 3. Okay. So 123 as the sum is 6, which is divisible by 3. Yes, we can say that 123 is divisible by 3. Let's try to take small examples. 126. How much is that? 6, 7, 8, 9. Just add the numbers. 9. 9, 10, 11, 12, 13, 14, 15. Okay. 8, 9, 10, 14. Okay. 5 plus 4 is 9. 9 plus 0 is 9. 5 plus 6 is 11. 11 plus 9 is 20. Is that correct? So these are the digits. So now the point is 9 divisible by 2? It's not divisible by 2. We are talking about divisibility by 3. We are talking about divisibility by 3. Okay. Sum of the digits is 9. Is it divisible by 3? Yes. 9 is divisible by 3. So I can say that the total 126 is divisible by 3. 15. Yes, it is divisible. 3 into 5. 14. No. 14 is no. 9. What about the 9? 9 is divisible, again it is divisible by 3. So the complete number 540 is divisible by 3. 20 is not divisible by 3. So this is how you can understand whether a given number is divisible by 3 or not. Divisibility by 2, even number, done. Divisibility by 3, sum of the digits should be a multiple of 3 or should be divided by 3, should be divisible by 3. Okay, next one. A number is divisible by 6. A number is divisible by 6. Now, when I discuss about 6, I know 6 can be written as 2 into 3. Right? Those two are prime factors, prime numbers 2 and 3 are. So I can say that if a number is divided by both 2 and 3, it will be definitely divisible by 6. So the only logic for 6 is it should be divisible by 2 and 3, and we know that for 2 it is an even number, for 3 the sum of the digits should be divisible by 3 again. Okay, so a number is divisible by 6 if a number is divisible by both 2 and 3. By both 2 and 3, correct? So let's move ahead. 504. 504, is it divisible by 2? Yes, why? Because 4 is an even number. Good. 9? No. 6? Yes. 9 again? No. But now what about divisible by 3? So we need to add the digits. 5 plus 4, 9. Yes, it is divisible by 3. 3 plus 3, 6. 6 plus 9, 15. Yes, it is divisible by 3. 2 plus 8, 10. 10 plus 6, 16. It is not divisible by 3. And 5, 69. 6 plus 5, 11. 11 plus 9 is 20. And this is also not divisible by 3. So the point here is 504, when we are taking by 2 and 3, as both the numbers are true, it is divisible by 2 as well as 3. It is completely divisible by 6. It is completely divisible by 6. Okay. What about divisible by 2 and 3? 2 and 3 divisible by 3. Okay. So as it is not divisible by 2, we can straightforwardly say that it is not divisible by 6. In the same way here, 286, it is true for 2 but not for 3. So still it is not divisible by 6. And here both the things are false, and you can say that it is not divisible by 6. It should be divisible by both 2 and 3. 2 and 3, and means both of them. It's not just 2 or 3. In some cases, if you find 2 or 3, or means any one can happen. And means both of them should come. Both of them. I or Ravi and Raju are going to market. Ravi and Raju means both are going. Ravi or Raju, that means any one person is enough to go to market. Okay, right. So the next one, every even number divisible by 3 is divisible by 6. So if there is an even number, definitely we can say that it is divisible by 2 already, and again divisible by 3. So the total count can be divided by 3, by 6. Right. We started with 2, we started with 3. 2 into 3, we started with 6. Okay, so let's move ahead to know the next divisibility rule. Okay, we have a small question here. What is that? Which of the following numbers are divisible by 2, 3 and 6? By 2, 3 and 6. Let us try to take the number 3217. Again, the same type of process. I'm not going to do it completely. Okay, I'm leaving that for you. I'll just try to discuss one or two. 3217. Is it an even number? No. It is enough. I will not check that. It is not divisible by 6. But for 3, what we do? We just add these two. 3 plus 2, 5. 5 plus 1, 6. 6 plus 7, 13. 13 is not divisible by 3. 4, 3, 3, 5, 0, 4, 5, 6, 7, 8, 9, 10. 10 plus 5, 15. 15. Sum of the digits is 15. Yes, it is divisible by 3. And here, the last digit is 0. Yes, it is an even number. As these two are true, it is divisible by 6. The same way you can proceed with the remaining things. Right. So let's move ahead for the next one. Write the smallest digit and the greatest possible digit. Understand? Try to understand properly. Write the smallest and the greatest possible digit in the blank space of each of the following numbers so that the numbers formed are divisible by 3. Divisible by 3 means sum of the digits should be 3. Sum of the digits should be multiple of 3. Okay. First of all, let us try to add all this. 6 plus 7 is 13. 13 plus 2, 15. 15 plus 4, 19. Once again. 6 plus 7, 13. 13 plus 15. 15 plus 4 is 19. Okay. Now for 19, what is the nearest number that you can add so that the number is a multiple of 3? 19, no. 20, no. 21. 21 is a multiple. So 19 plus 2 will give you 21. 19 plus 2 will give you 21. So I'll keep 2 here. So I'll write a new number. 26724. 26724. It is a number divisible by 3. It is a number divisible by 3. You can carefully check that. 6 plus 2, 8. 8 plus 7, 15. 15 plus 2, 17. 17 plus 4, 21. 21 is exactly divisible by 3. Okay. So this is the least number or the smallest number. Why this is smallest? Because we just took the nearest number 2. Let's move ahead and go with the more digits. 19 plus 9, 19 plus 9, 28. Is it divisible by 3? No. 19 plus 8, it is 27. Is it divisible by 3? Yes. So the other number we can keep it here is 8. Okay, so that number will give you 8, 6, 7, 2, 4. So 8 plus 6 is 14, 14 plus 7 is 21, 21 plus 2, 21 plus 2 is 23, 23 plus 4, 27. The sum of the digits is 27. Yes, it is divisible, and this is the greatest, or you can say the highest number, which is divisible by 3. In the same way, you can try to find these two. 4, 7, 6, 5, some number with 2. Just add the numbers. 4 plus 7, 11. 11 plus 6, 17. 17 plus 5, 22. 22 plus 2 is 24. Once again. 11, 11 plus 6, 17. 17 plus 5, 22. 22 plus 2, 24. Yes, it is exactly divisible. It is exactly divisible by 3. So, the least number you can go is with 0. The least number you can go is directly with 0. You can keep 0 here. You can see 4, 7, 6, 5, 0, 2. 4, 7, 6, 5, 0, 2. Yes, it is the least number that can be framed here such that it is divisible by 3. In the same way, you can find the greatest, and you also please try to do that. A very simple approach. A very, very simple approach. Okay. No complications are here. Let's move ahead. Let's try to understand about divisibility by 9. We discussed divisible by 2, by 3, and we also discussed by 6. Okay. Now, let us try to understand the divisibility by 9. 9, again, the same thing like 3. The sum of the digits should be a multiple of 9. The sum of the digits, a number is divisible by 9 if the sum of the digits is divisible by 9. Is divisible by 9. Okay. Let's take few numbers. 504 again. 5 plus 4 is 9. So now tell me, is 9 divisible by 9? Yes. 72954. Well, let us try to add. 7 plus 2, 9. 9 plus 9 is 18. 18 plus 5, 23. 23 plus 4, 27. Once again. 5 plus 4, 9. 9 plus 9, 18. 18 plus 2, 21. 21 plus 7, 28. So now tell me, 28 is it? It's not 28, I'm sorry. 5, 4, 9. 9 plus 9, 18. 18, 20, 27. Okay. 27. Is it divisible by 9? Yes. 186. 6 plus 8, 14. 14 plus 1 is 15. Is it divisible by 9? No. So 186 is also not divisible by 9. 369. 6 plus 3, 9. 9 plus 9, 18. 6 plus 3, 9. 9 plus 9, 18. Okay. 18 is again divisible by 9. Yes, that is correct. Are you understanding how to do all this? Just add the numbers and see if it is divisible by 9, yes or no. Okay, so let's move ahead. Let's try to understand about divisibility by 5, and with this we'll stop it here. Okay, numbers with 0 or 5, numbers with 0 or 5 at one's place, 0 or 5 at one's place are divisible by 5. You can see the table 5. 5 into 1 is 5. 5 2s are 10, 15, 20, 25, 30, 35. All these numbers either end with 0 or 5. Okay. 5 is the multiple 10, 15, 20, 25, 30. So all these numbers either end with 0 or end with 5. So the unit digit should be either 0 or 5. Okay. So let's try to take unit digit is 5. Number in one's place, yes. 0, okay, yes, that's correct. 9, no, so it is no, it cannot. 5 again, yes, it is divisible by 5. Number in one's place is 5. Here it is 9. Right? So are you understanding how to see whether a number is divisible by 2, by 3, by 5, by 6 and by 9. So furthermore, going towards in the next class, we're going to discuss about divisible by 10. And after that 10 also we have more applications like divisibility by 4, divisibility by 8, divisibility by 11, and so many other things which we are going to discuss in the next lecture, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today we'll be discussing about sound. That is, we'll be starting with production of sound, which means how is sound produced. We'll learn about that. Okay. My name is Seshan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first thing is, what is sound? What do you think sound is? Sound is one of our senses. Sound is one of our senses. So now we hear sound, right? So sound is a form of energy which produces a sensation of hearing in our ears. That's it. Sound is a form of energy which produces a sensation of hearing in our ears. So our target for this chapter will be, how does sound do this, or how do we hear different sounds and how are different sounds produced? We'll be learning about them. Okay, that's good. Let's continue. So the first thing is, we have many questions in our mind. As I told, we do have many questions, right, when it comes to sound. How is sound produced? Basic question. How does sound travel? See, I am speaking. Now you are listening to me. How is that happening? How does it travel? Right? Then how are different sounds different from each other? My voice is different from my friend's voice. In fact, your voice. Yes or no? So how is my voice different from your voice? Another very interesting question. Right? And how do we hear this sound? Until now the questions were how to produce them. Now here, actually how do we hear? Obviously we know we use ears, but how do those ears work? We'll be learning about them. Okay? Good. So first comes this. Now how is sound produced? Now whenever or wherever sound is produced, just look at what's happening. Now for an example, look at this guitar string. So when you play a guitar string, look at these strings. What's happening to them? What's happening to them? What can you notice? Obviously when you pluck the strings, sound is produced. When you pluck the strings of a guitar, sound is produced. And what's happening to those strings? It's a slow motion picture, so please look at that. You can clearly see that the strings are vibrating. Can you see that? The strings are moving up and down. They are vibrating. So here, when the strings produce sound, they are vibrating. Okay, that's something we noticed. But does this happen with all other cases? Let's go into that also. Let's go into a few other examples. Look at this here. When you hit it, sound is produced. But when you hit it, look at the slow-mo, even that is vibrating. Yes or no? So here also sound is produced, and when sound is produced, there is a vibration. Okay, that's fine if that's about musical instruments. But what about a speaker? Now, when speakers produce sound, they also have a diaphragm, a membrane, and you can clearly see that it is also vibrating. Very small speakers to very huge speakers, they work on the same principle. They have a diaphragm which vibrates. And what does vibration do? Here vibration produces sound. So in all the three cases that we have seen, whenever sound is produced, there is some sort of vibration. Now forget about this. Let's look at ourselves. Take your hand, gently, very gently, do not press it hard, very slowly, you just have to feel it. So place it near your neck like this. Now start talking, talk something. Just make a sound, any sound. Can you feel the vibration? Can you feel something is vibrating there? Yes or no? Yes. So there also, even when we talk, even when we produce sound, we can see that there is some sort of vibration. We can feel it, not see, we can feel it. Right? So that from all of these examples, what we can understand is, whenever there is a vibration, sound is produced. So how is sound produced? From vibrations. So our first task is to understand what vibrations are. Because sound is produced from vibrations. So if you understand vibrations, then you can understand sound. So let's go into vibrations also then. Now what are vibrations? To and fro motion of an object. Simple. Remember these words. These are, let's say, some keywords. To and fro motion of an object is called vibration. Simple. Right? And sound is always produced By what? By a vibration. So if sound is produced, that means there is a vibration. Whether you can see it or not, that's a different matter, but there will be vibration when sound is produced. Good? Okay, that's good. Let's continue. So now every vibration has some characteristics, properties. What are they? One is called as amplitude, the other is called as time period, and the other is called as frequency. So it's important that we understand all these three so that we can understand different type of sounds. Because sound is produced from vibrations, so we have to go into all of them. Okay, let's go into amplitude first. Now this is also an oscillation, as you can clearly see, or you can say a vibration. Like it's a swing, it's like a swing. So it's going from here to here and then again coming back. It's like to and fro motion. Going towards it, coming from it. Going to and coming back from. So to and fro motion. To and fro motion. Now the question is, what is amplitude? I'll just explain that to you. See here. That is a pendulum, okay? We know what is that? A pendulum. We generally use pendulum to understand vibrations or oscillations for that matter. Now when the pendulum is not moving, how will it be? It will be simply vertically down. Yes or no? That's how it's going to be, yes? So this is what this is, its natural position. Or you can say mean position. Or you can say equilibrium position. So there are different words for it. You can take any word, it's up to you. So when it is not moving, when the pendulum is at rest, its position is what? Natural, mean or equilibrium position, whatever you call it. Now, what do? You just shift it slightly, either towards right or towards left, and then leave it, and what happens then? The pendulum oscillates. The pendulum oscillates, yes or no? So let's say this is the maximum distance until which it goes. It's like a swing. If you are on a swing, you will go up and you'll go back. You'll go front and you'll go back. But do you keep on going? No. You go and stop somewhere. There is a maximum distance. Yes or no? So that maximum distance, this maximum distance, from where? From the natural position or from mean position. Let me write it as from mean position. Is called as what? Is amplitude. Is amplitude. And obviously different oscillations have different different amplitudes. So yes or no? If there are two swings, your friend and you are on two swings and you are trying to compete with each other, who will go more up? Yes or no? One of you will be leading, one of you will be falling back. There also you have different amplitudes. Yes or no? It also depends on how fast you are swinging. Right? Similarly, here amplitude is what? Maximum distance from the natural position. Now you might think, sir, why are you only taking to the right side? You can also take to the left side, it will be the same. Okay. If this is 10 centimeter, this will also be 10 centimeter. I am giving an example. So for amplitude, you can take the maximum distance on the right side or on the left side. Doesn't matter, it will be the same. So what is amplitude? Maximum displacement or maximum distance from what? From the mean position. Got it? So it is the distance between the mean position and the extreme position. What does extreme position mean? These are extreme position, or you can call them as end position. It's up to you. Okay. Here also you can say end. I'll just write end, or you can say extreme. Extreme or end position. Got it? Understood? So here, that's what amplitude means. Simple. Okay, now what is the specialty of amplitude? There is one relation, okay? Louder the sound, greater the amplitude. How? Let's say there is a table. There's a table in front of you and you are hitting a table. Not with your hand, let's say with a stick. Okay? You are hitting the table with a stick. You hit it slow and you hit it hard. When you hit it slow, its amplitude will be less. But when you hit it hard, its amplitude will be greater. Yes or no? The amplitude of vibrations. And their loudness will be different. So loudness depends on amplitude. We will discuss this point later on. But I'm just showing you how sound depends on the vibrations. That is why it is important. So please understand this very carefully. And amplitude is the simplest of them. So what is amplitude? The maximum displacement or maximum distance between the mean position and the extreme position. Simple? Good. Let's continue. Now we'll go into something called as time period. Now what is this time period? It's very simple. Remember the definition of time period. It's helpful always. If for periodic motion, it could be for oscillations, many places. Circular motion, rotations, revolutions, all of them. Periodic time period is important. So what is time period? It is nothing but time taken for one complete vibration, for one complete motion. I'll give a simple example. Time period of rotation of Earth. How much is that? How much time does Earth take to complete one rotation about its axis? How much? 24 hours. What is the time period of revolution of Earth around the Sun? How much time does the Earth take to complete one full orbit around the Sun? How much time? 1 year. Yes or no? So you already know the basic idea of what time period is. Similarly, for an oscillation also, for a vibration also, there will be time period. It is a time taken for one complete vibration or one full oscillation. What does that mean? That means if it is starting from here, going towards right and coming back, that is one complete oscillation, and the time taken for that one complete oscillation is how much? Or is called as what? Is called as time period. The usual symbol for time period is capital T, capital T. And obviously time period is nothing but time taken. So what will the units be? The SI unit will be seconds. SI unit will be second. Because ultimately time period is nothing but time taken. For time taken, the units are what? Second. It's not anything special. Very simple. Understood? Right? So what is time period? Time taken for one complete oscillation. It starts from here, goes to right and comes back. One complete oscillation. So let's go into a few examples. One simple question here. What is the question here? If a pendulum completes 3 oscillations in 2 seconds, find the time period of the pendulum. That is the question. Okay, let's try doing it. Completes 3 oscillations in 2 seconds. You have this and you have to find the time period of the pendulum. It's very simple. What is given here? 3 oscillations in 2 seconds. So what you have to understand is, what is time period? Time taken for one oscillation. But how many oscillations you have here? 3. But we need 1. How do you get 1 from 3? You divide by 3, and whatever you do, you have to do both of them. Yes or no? So you just divide by 3 and see what happens. 3 by 3 is how much? 1. So one oscillation in how much time? In 2 by 3 seconds. So time taken for one oscillation is what is time period. So time period is 2 by 3 seconds. And what is 2 by 3? It will be equal to 0.67 seconds. You can do the division. Yes or no? 2, 3. Then it is 0. You get a 0 here. 3, 6 are 18. Then again you get 2. It goes on. So you get 0.6666. It keeps on going, and that will be 0.67. So that's it. You got time period. And this method is called as unitary method. You'll learn that in maths. But I told you what to do. If you need 1 here, you divide 3 by 3. And there also you have to divide by 3. Just don't do it one side, you have to do it on both the sides. That is the important step. And after that, it will be very simple. And this method is helpful many places. Okay? Good. So what is the time period? Time period will be 0.67 seconds. Option D in this case. Simple? Good. Let's continue. Then we'll talk about something called as frequency. What is frequency? Okay. Now I'll ask you something. If you just look at your friend's eyes, how many times does your friend, he or she, blink in 1 second? Blink your eyes in 1 second. How many? Some of your friends might not blink, 0. Some of your friends might blink once. Some of your friends might blink twice, some 3 thrice, some 4 times, right? It depends on your friend to friend, person to person. Good. Thing is, how many times does he or she blink in 1 second? 1 second, that number is called as frequency. That number is called as what? Frequency. So frequency is nothing but the number of oscillations or vibrations per second. When I say per second, that means in 1 second. Got it? So there is a simple formula. I'll show that formula. Don't worry how this formula came and how to do it. I'll show it to you. I'll go into that. Don't worry. I'll go into those points. Look at this. Let's say we have 30 oscillations in 10 seconds. What is frequency? Frequency is number of oscillations in how much time? In 1 second. So what's our target? Our target or our goal is to get 1 second here. 10 seconds are here, but we need what? 1 second. That means you divide by 10 in this case. And what is 10 by 10? 10 by 10 is 1. So you'll get 1 second. But I told you, you have to divide on both the sides. So you have to divide here also. And when you divide, what will you get? You get 30 by 10. How much? 3. That is 3 oscillations. In 3 oscillations in how much time? 3 oscillations in 1 second. 3 oscillations in 1 second. Is that clear? So now coming back, look at the definition of frequency. Number of oscillations in 1 second. And what is the number of oscillations in 1 second? 3. So that 3 is frequency. That 3 is what? That 3 is frequency. And how did we get this? We got it from this calculation. F is equal to 30 by 10. Now look at this carefully. 30 by 10. What is the number 30? From where did we get 30 here? 30 is the number of oscillations given. 30 is what? Number of oscillations. And what is 10 here? 10 we got from time. Yes or no? So 30 is number of oscillations and 10 is for time taken. That's it. We got the formula. So for number of oscillations, I'll call it as capital N. Time taken, I'll call it as T. So frequency is equal to number of oscillations upon time. If you know this, you can easily do it. Or else you can use this method also, unitary method. Anything is the same. Good? So just remember this, number of oscillations in 1 second. So to get 1 second, its corresponding number will be what? Frequency. Understood? Good. So see, we got the formula, frequency is equal to capital N by T. Now let me warn you here itself, or let me suggest you or advise you here itself. In physics, not only in physics, in chemistry, in biology, all the science subjects, frequency and time period is one or two very important terms. They will not leave you. They will be coming regularly. What? Frequency and time period. So it's very important to understand frequency and time period clearly. Whatever stream you take, it could be science or it could be anything else. Those are important. Okay, so please carefully understand them and carefully practice the questions also. Good? Okay. So let's go into a simple question, but before that there is one point. The SI unit of frequency is Hertz. Because if I look at the formula, frequency is equal to number of oscillations upon time. If I look at the units, number of oscillations have no units. That is no units. But for time, the units are what? Seconds. So the units of frequency will be 1 upon second. Or else you can say per second. Per second. Or you can say s to the power minus 1. Both of them are the same. So to show this comfortably, we use what? We use something called as Hertz. What is the symbol? Capital H and Z. So this is the unit or the SI unit of frequency. And what is Hertz? 1 Hertz is equal to 1 per second. 1 per second. Simple. Okay, just remember that whenever the time taken is in terms of seconds, the SI unit of frequency will be hertz. The symbol is capital H and Z. Good? Okay. A simple question we have here. Now same question, but we have to find out frequency, I think. See, if a pendulum completes 3 oscillations in 2 seconds, find the frequency. Last time we did what? Last time we calculated time period. Now we have to calculate frequency. And what is that here? 3 oscillations in 2 seconds. 3 oscillations in 2 seconds. And remember the definition. Remember the definition of frequency. What is the definition? Number of oscillations. Number of oscillations in how much time? In 1 second. So what is our target here? Our target is to get 1 second. So how will we get 1 second here? Time is 2 seconds. How will you get 1 second? Divide by 2. Divide by 2. So that means here you have 1.5. 3 by 2 is 1.5. 1.5 oscillations in 1 second. What is frequency then? In 1 second, the number of oscillations, how much? 1.5. So that is frequency. Frequency is equal to 1.5. But what about the unit? The unit will be hertz. Time taken is in terms of seconds. So automatically the unit of frequency is hertz. That's it. Or else, obviously we can use the formula also. F is equal to N by T. N is what? N is the number of oscillations. According to the question, we have 3 oscillations, and what is the time taken for that? 2. 3 by 2, what is 3 by 2? 3 by 2 is going to be 1.5, and the unit of frequency is hertz. So 1.5 hertz. You can use this or you can use this, it's up to you. This method is what? Unitary method. What do you call it as? Unitary method. In detail, you will be learning it in maths. Got it? Simple? Okay, so that's frequency. Now there is an interesting formula between frequency and time period. Again, important. But how did we get this formula? I'll explain. What is the formula for frequency? Capital N by T. Simple. Now, for one oscillation, what is the time taken called as? Time taken for one oscillation is called as time period. So time will be what? Time period. So when I say one oscillation, N is equal to 1. Number of oscillations is equal to 1. And we got the time period as capital T. So if I use that here, if N is equal to 1, time is time period. Yes or no? One oscillation, what is time taken called as? It is called as time period. So when N is equal to 1, number of oscillations equal to 1, the time taken is time period. If I use them here, in place of N1, in place of time period, and we get an interesting formula between frequency and time period. What is that formula? That formula is frequency is equal to 1 by time period. Frequency is equal to 1 by time period. It's a very important formula. Understood? Frequency is equal to what? 1 by time period. Good? Okay, so that means we got the formula. Good, so we understood what amplitude is, what time period is, what frequency is. We got the formula between frequency and time period also. We'll go into a few questions. Okay. So we have a simple question here. If the frequency of a tuning fork is 2000 Hertz, frequency is given, what is the time period of the tuning fork? Now how will we do it? Very simple, straightforward question. Given information, frequency is 2000 Hertz. What we have to calculate is time period. What is the formula? Frequency is equal to 1 by time period. If you do the reciprocal on both the sides, what will you get? You will get 1 by F is equal to time period, or time period is equal to 1 by frequency. You can just interchange them, it's fine. So if I use that formula, time period is equal to 1 by F. What is frequency? 2000. So it is 1 by 2000. You have to just calculate. What is 1 by 2? 0.5. Yes or no? So it is 0.5 divided by 1000. So it is going to be 0.0005. Now 3 zeros, right? So according to that, the answer will be not that. Just a minute. Oh, sorry. Let's write it down again very quickly. Frequency is 2000 hertz. Frequency is 2000 hertz. Time period is equal to what? 1 by f. You can interchange f and t. It's fine. Formula works that way, right? So time period is equal to 1 by frequency, 1 by 2000. I can write 1 by 2000 as 1 by 2 into 1 by 1000. It is the same. 2 into 1000 is 2000. What is 1 by 2? 1 by 2 is 0.5. It is 0.5 divided by 1000. You have 3 zeros. You have to shift the decimal by 3 places. So you'll get 3 zeros. That's it. You'll get that in SI units. The SI unit for time period is seconds. 0.3075, and the correct answer is option A. Very simple. The tricky part could be the calculation itself. Everything else is C. Pretty straightforward. Good? Okay. Next question. If the frequency of a tuning fork is 2000 hertz, how many vibrations does it complete in 1 minute? What is the time period of the tuning fork? Okay. I think time period we already got it. We are not concerned with that. We have to calculate what? We have to calculate how many vibrations does it complete in 1 minute. So let me write down the given information and let's use it. Given information is frequency is equal to how much? 2000 hertz. Then time is given as how much? 1 minute. See, minute. We have to convert that into seconds. So 1 minute is 60 seconds. And we have to find out how many vibrations does it complete. The total number of vibrations. How do we do that? We can directly use the formula. Frequency is equal to capital N by T. If I bring T to this side, it becomes frequency into time period is equal to capital N, or N is equal to frequency into time period. That is, number of vibrations will be equal to frequency multiplied with time. So here if I do that, N is equal to F into T. What is frequency? 2000. What is time? 60. How many zeros are there? 3 plus 1, 4 zeros. 6 into 2 is 12. And then you write down 4 zeros. So it comes around to be 1,20,000. This is the number. 1,20,000. So, and that is what? Option C. Simple? Good? Okay. That's good. So, the first step that we have discussed is what? Vibrations produce sound. So, we understood that point. We also learned a few properties or the characteristics of vibrations. Good? Amplitude, time period and frequency. Now, there are other steps in understanding sound completely. One is sound travels through a medium. So, you have to understand how sound travels. And then we also have to understand how sound is received by our ears and processed by our brain. We'll do that. We'll keep learning that in the further classes. But for now, the first step is done. Okay, so please understand the concepts, right? And frequency and time period, as I told you, is very, very, very important. So please practice. Okay, so that's it, everyone. Thank you. Thanks a lot.